Hello and welcome. This is Additional Mathematics Form 5 Kssm textbook question chapter 2 differentiation. So in this video I'm going to go through formative exercise 2.3. My name is Terry. If you like our video, please click like, and if you want to receive more notification when we upload a new video, please subscribe, and always give a comment if you have any question that you're unsure of, or if you think that there's certain area that we can improve in this video presentation. So let's get straight to this. Okay, so the first question is, we are supposed to show that x squared d square y dx square plus x dy dx is now y. So before you find this, we need to find what is our dy dx. To find dy dx, right, we have to make y as a subject. So I need to rearrange this equation by bringing this over. So, and my y is now 2x plus 3 over x. So when I differentiate dy dx, I should get 2 minus 3 over x squared. I hope you remember the techniques of differentiation. And now particularly this, I'm using the fast way. I put a negative in front, a times n, copy x, increase the power by 1, right? So this is a shortcut method to differentiate in the event that x is below. I know most people would have brought this up, and then when they differentiate, they bring the power down, you copy x, reduce the power by 1, and then they bring this back down. But this method is a bit slow, right? I will just have to put a negative in front. As you can see, I put a negative in front here. I copy 3 times 1, which is 3. I copy x and increase the power by 1. So this is a differentiation technique for reciprocal term. So if I differentiate one more time, when you differentiate 2, you get 0. Differentiate negative 3 over x squared. If you put a negative in front, it'll be positive. 3 times 2 is 6. Copy x, increase the power by 1, you get 3. Okay, to show that this equation is true, we always start from one side, and now in this case I'll start from the left hand side, the LHS, short form for left hand side. I'm going to put d square y dx square inside, which is 6 over x cubed. I'm going to put dy dx inside, 2 minus 3 over x squared. Just multiply together. We can cancel x cubed and x squared, you get 6 over x. Multiply inside 2x minus 3 over x, and if you put together 6 over x minus 3 over x is just 3 over x, and this is the same as your y value, you can see, which is the same as your right hand side. Okay, moving on to question number 2. So here we have to find f prime 1 and f double prime 1 for the following function. So the first part, when I differentiate 3x, I get 3. Differentiate negative 2x cubed, I get negative 6x squared. So let us put 1 inside, you get 3 minus 6. Now 1 times 1, if you sub inside your x squared, is still 1. So can I just write 3 minus 6, which is negative 3. Now f double prime x means we have to take this f prime x and you differentiate one more time. So when I differentiate 3, I get 0. Differentiate negative 6x squared, I get negative 12x. And again, if you substitute 1 inside your x, this is just 1. So you get negative 12. Part B, I think it's easier to expand the bracket first. So I multiply inside, I get 5x cubed minus 3x squared. So when I differentiate this, I will get 15x squared. 3 times 2 is 6. Copy x, reduce the power by 1. This is 6x power 1. And when I put 1 inside, I'll get 15 minus 6, which is just 9. Just 9. Okay, now the next one is, when I differentiate 15x squared, I'm going to take my f prime x and differentiate one more time. We write this as f double prime. 15 times 2 is 30. Copy x, reduce the power by 1. Differentiate 6x, you get 6. As we put 1 inside, I get 30 minus 6, which is 24. Now for part C, it's actually easier when I split them into 2, x cubed over x squared plus x over x squared. So we can cancel, get x plus 1 over x. Now notice the difference between x cubed plus 1 over x squared, let's say this, and x cubed plus x over x squared plus, let's say, 1. If you have a single term, it's actually easier if you separate them and simplify first before you differentiate. If you have 2 terms, you cannot separate them. You have no choice but to use quotient rule. Y equals u v u prime minus uv prime over v squared. I hope you remember that, right? So here, when I differentiate the first round, I get 1 minus 1 over x squared, and as I put 1 inside, I will get 0. Okay, the second time you differentiate, you should get, if I differentiate 1, I get 0. I'm differentiating this. Differentiate this with 2 over x power 3. Then when I put 1 inside, I will get 2. All right, moving on to question number 3. Okay, so question number 3, we have to use composite function. So the first thing I would do is maybe I'll write this as x squared minus 5 power half. When we differentiate composite function, we bring the power down, we copy the bracket, we reduce the power by 1, and you differentiate inside the bracket. So here the 2 and x and 2x, I can cancel these two, right? And I'm left with just x, and if I bring this down, I will get square root x squared minus 5. Now I hope you know this, if I have x power negative 1, this is 1 over x. If I have x power half, is square root x. And if you have x power negative half, this is just 1 over square root x. So just bring the whole bracket down. Okay, and the first part, you're supposed to find f prime 3 here. So I'm going to put 3 inside, 3 squared minus 5. So this will be 9 minus 5 is 4, square root of 4 is just 2. Okay, the second time you want to differentiate this, right? Maybe it's better to use uv because the bracket is below, right? The square root x squared minus 5 is below. So when you use uv, remember the formula goes like this, vu prime minus uv prime over v squared. My v is x squared minus 5 power half. U prime, when I differentiate x, I get 1. My u is just x. V prime will be, bring the power down, copy x squared, reduce the power by 1, differentiate again. Now this is actually identical to the first part here because your v is exactly the same as your fx. Okay, then you divide by v squared, x squared minus 5 power half squared. Now I'm tempted to simplify this, but you don't have to simplify this because after all, we're finding f prime negative 3, f double prime negative 3. Yes? So this is double prime here. I better write this double prime here. So now we are going to put negative 3 inside here. You square it, minus 5. Power half is a square root. This will be, can I cancel this too? This will be x squared. X and x times together, guys, is going to be x squared. So I'm going to put negative 3 here. I square it. And power negative half is just 1 over negative 3 square minus 5. Then, oops, this is a bit ugly. And we can just cancel x squared, cancel this half and 2. You're left with negative 3 square minus 5. So square root of 9 minus 5 is 4. Square root of 4 is 2. This will be 9 over 2. Divide 9 minus 5. Yeah, so can I just write 4, right? So this is just 4, right? I'll just write 4. Don't write so many things. So 2 minus 9 over 2 minus divided by 4 is negative 5 over 8. All right, moving on to question number 4. So here we are supposed to find the value of d given that dA dt equals to d squared a dt squared. So we'll just differentiate the first time. You get 3d squared plus 4d plus 3. When you differentiate the second time, you get 6d plus 4. So I'm going to sub inside my dA dt and d squared a dt squared. So 3d squared plus 4d plus 3 equals 6d plus 4. Just bring over. 4 minus 6 is minus 2. 3 minus 4 is negative 1. We can double bracket factorize this, plus and minus. So d is negative 1 over 3 or 1. Okay, fairly simple, right? All right, let's move on to number 5. So here you're finding g double prime 1 equals to 4. Find h. So g single prime, the first time you differentiate, you bring the power 3 down, copy h, copy x, reduce the power by 1, 2. Differentiate 4x squared, 4 times 2 is 8, copy x, reduce the power by 1, differentiate 5x is 5. Second time we differentiate, 3 times 2 is 6h, copy x, reduce the power by 1 is 1. Differentiate negative 8x is negative 8. And I'm supposed to put 1 inside and let it be 4. So when you substitute 1 inside, you get 6h. 8 I bring over, I get 12. H is 12 divided by 6, which is just 2. Okay, and the last one, number 6. All right, so find the value. Okay, we have part C. Yeah, I think we have 2 parts here. Okay, find the value of x such that f prime x is 0. Okay, so when you differentiate first time, you should get 3x squared minus x squared minus 8. Minus 2x minus 8, sorry. So the second time you differentiate, okay, I just find my x value first, yeah? So I'm going to take 3x squared minus 2x minus 8, let it be 0. Double bracket factorize 3x, x, 2, 4. This will be a minus and plus, so x is either minus 4 over 3 or 2. Okay, now second part, you're supposed to do f double prime. That means we differentiate one more time, and we'll just take this function and differentiate one more time. I get 6x minus 2. Okay, I don't want to show you part C on the next page because I find it's actually easier if I show everything here. Part C is actually find x such that f double prime equals to 0. So I'm just going to write 6x minus 2 equals 0. 2 divided by 6 is 1 over 3. And part D, find the range of value of x such that f double prime x is less than 0. So if this is less than 0, we can solve for x. Again, it's the same figure. It's still 1 over 3. So x is less than 1 over 3. Alright, yeah, we're coming to the end of the video. So just take note, yeah, that if you need any additional help, tutorial question or tuition classes, we have lots of material learning videos with manual solution, modules, right? And for your to help you to do better in the subject. So we also have tuition classes. If you're interested, you can contact us, yeah, through WhatsApp or call us or visit our website. Thank you for watching. I hope you learned a lot from this video. I'll see you in the next one. Right.